All right. All right. This is our second session. And do you have any questions before we start with second session? Today we will discuss the various ways you can run Spark. How you can download and get started, in what all modes you can start it, then run a sample programs in all the three modes, and after that we will continue with our discussion on Python. All right. So before that, do you have any questions for me? All right. So Jiten, we will cover Scala in brief. All right, we'll cover Scala in brief. We'll give you an overview. Okay. The way we'll cover Python in brief, we'll also cover Scala in brief. All right. After starting the course, we realized that lots of people are asking for Scala. So I think it makes sense to cover the basics or the overview of Scala. All right. So also, since it's a small class, so I would like to, take the introductions from you, and so I'll unmute you one by one, and you can introduce yourself, and then we can carry on the discussion. All right? Is that comfortable for you? So, Abhishek, can I unmute you? Hi. So, are you able to hear me clearly? So, Gaurav, Hiren, can I unmute you? So that you can give an introduction, because we are only three, four people, so it would be great to hear your voice. And okay, okay. Jitendra, will it be comfortable for you if I unmute you and you introduce yourself? All right, I'm unmuting you. Go ahead.
Hi, can you hear me?
Yes, I can hear you.
Hey, I'm Jitender, and currently, actually, I'm working in like I'm a data writer from 16 year, and I'm working in different technologies basically. My main role is designing the model for the data to consume in a data warehouse. Basically, it's the ETL jobs, right? And I do modeling and all kind of stuff. So recently, from last 1 year, I moved into this big data. So, like, I'm working for a company called AT&T, where we are moving the data from the big data into the Teradata. Okay, but why I joined this class so that I learn more on the big data stuff, because right now I'm just doing a design on the same concept using the RDBMS, not like a data. So I want to go really into that, understand more on architecture so that I can understand how we can, do a capacity planning or how the data pipe will be there for the big data to go into basically our relational model. Okay.
Okay. Okay. Great. Great. Great to know about you, Jitender. All right. Thank you. All right. So, Mehdi, can we unmute you? Will you be comfortable? Yeah. Go ahead.
Hi, good evening, everybody. Hi, this is Mehdi. I'm
Yeah.
working for DoD, Department of Defense. My current job responsibilities is as an Informatica developer. Basically, currently I'm doing medical billing, validity of medical billing,
Mhm.
and we have a data warehouse. That's what we're maintaining the data warehouse as well as the big data. So last almost like 9 months now we're moving to big data. So in my current project, it's required to have knowledge in big data. That's why I'm in here. So I did a lot of Google and I find out that Spark is one of the best tool in Hadoop ecosystem. And in Spark there is other ecosystems like streaming, ML Live,
Yes.
and
Yes.
Graphite and others. So in Spark we can use the SQL, we can use R, we can use Python, and we can use also Hive code in Spark. We can use H-based code in Spark. So this is a
Yes.
wonderful tool that I'm very
Great.
interested in
Great.
Spark.
Great. 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 Great.
Thank you.
Thank you. Thank you, Mehdi. All right. Thank you. Great. Iswar, would you like to introduce yourself? All right. So I think Ishwar is not around. Ishwar, are you able to hear me? All right. So are you comfortable if I unmute you? Okay, I'm unmuting you. Okay. Good. Go ahead, please.
Myself, Iswar Krishna. I'm currently working as senior systems analyst in uh, UST Global. Um, my current work is related to something to do with the locations that you get from different infrastructures, stuff like that. Uh, so I am mainly currently working on some latest technologies like Apache Spark, Apache Storm, and Kafka related stuff. So I think in near future, as the Storm and Spark are almost close in some areas like revenge streaming, I thought like I would enroll to this course actually. Uh, I have totally 8 years of experience. That's pretty much from my side. I'm in Bangalore.
Okay, great, great, great to know you, Ishwar. All right. Uh,
That's pretty much.
okay. 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 All right. All right. So yeah. So everybody's comfortable with the architecture part of it, like what are the components, the ecosystem, which are part of Apache Spark. Is everybody comfortable? Or should I give a quick review of what we had discussed earlier? This is the second class, and All right, a little bit of a recap, and then we'll start with the hands-on, as in the live one. All right, let me just explain to you in this diagram. Okay, so Spark is essentially a fast, fast computing platform, as in it makes our code run parallelly on multiple machines in a really, really fast manner. Okay, so you or your API can get the work done through Spark over a cluster which is having Hadoop installed on it. Or if you have a cluster on EC2, you can start Spark there. Or you just have one single machine you can run standalone for testing purposes. Or if you have a cluster of mesos, you can run on top of that. All right. Now, so when we say computing, computing is generally over the data, right? And so Spark basically helps you churning the data which is coming from HDFS, HBase, Hive, Tachyon, and Cassandra, all kinds of data sources, and it runs on any of these clusters. Okay. So the core strength of any of these big data products is they can run parallelly on multiple machines, and almost all of the tool almost all of the tool try for data locality. Data locality means taking the code to the data, which means if you think about it, while Spark is running on Yarn, it can talk to HDFS and get the work done closer to the place where HDFS is. Similarly, it can churn the data from HBase using EC2 or Yarn. All right. So this way, this is where Spark fits in. Spark does not have its own core data structure. Okay. It doesn't have its core data storage. Okay. It basically relies upon existing data storage. It's just a computing engine. All right. So that's a 1 minute review of Spark. Now, instead of writing code directly in Spark, so when we say writing code directly in Spark, you can directly write your functions, get them executed, or you could ask Spark to execute SQL. All right. So let's say there is some data which is lying in HDFS or say HBase, and you want to filter it. Okay. Either you can write your code in Spark like a function which will filter that data, or you could write the same thing in SQL and say that please filter my data. Or let's say there is a file which is lying in HDFS. All you want to do is find unique words in it. Okay. Now, to do that, either you can use the Yeah. So to get that work done of finding unique words, you can either write in Spark, the in core Spark, like a proper code, or you can write in SQL, all right? And or you can do the magic in using Spark R. All right. So you can interact with higher level languages like R and SQL instead of using Python or the Scala. All right. Now On top of the basic functionality, Spark has started providing you brilliant libraries. One of the libraries is for streaming. Okay, for streaming, you can, when it's a common task to consume a stream coming from various source. So let's say the data is coming at a very fast rate or continuously. It's coming from a queue. All right. So the difference between stream processing and normal program is normal program ends while stream processing never ends. Stream processing keeps on going. It doesn't end. All right. So, and stream processing generally requires really fast computing. So a stream processing requires a fast computing, and Spark is extremely fast, so it is fairly suitable for for processing a stream in which the data is coming at something like at a very fast pace, and the kind of output you require is the processing you require is on a per second basis, not a millisecond basis. If you have to do the processing on millisecond basis, then probably you would like to use Storm. Okay, so if you require output which is to be processed on per millisecond or less than a second basis, then you go for Storm kind of model. While for most of the practical senses, if you are looking for within a second kind of processing, then Spark is good enough for you. All right. On top of Spark, the basic library, the Spark has started providing you the MLlib. What is MLlib? MLlib is a machine learning library. For machine learning library, there are lots of functions, such as, let's say there is a big matrix which needs to be multiplied with another matrix. Okay, so if you have to code the same thing using Spark by yourself, it is actually a quite a complex process. So what these guys have done is they have made those libraries available. The Spark team and few more developers and engineers have written a brilliant library for doing lots of basic mathematical function required for machine learning, and they have embedded it in the MLlib. Similarly, the graph computation, when you have to say traverse a graph, so there are many algorithms which are already there, so which are already very stable and are required very frequently. So Spark provides all those algorithms along with a way to represent a graph. Okay, so they provide you a data structure. Data structure does not mean the way to storage, but a data structure is something in which you can load the actual data and process it easily. Okay, so GraphX also provides you the data structure to represent a graph on a massive scale. Okay, because when we talk about graph is what? Lot of nodes connected with, through the edges. You can think about Facebook. So on a Facebook, I am one node and you would be another node, and we might be connected as a friends, and we I would have some attribute, you will have some attributes. So if you think about it, everybody is connected through on the Facebook graph. Now if you have to do a computation, as in what is the average distance between the two persons, okay, or how can I how can I find out who are between me and Gaurav? Okay, through which I can seek the introduction. If you have to do these kind of computing, then GraphX is an ideal solution. Okay, because presenting a graph which is having a million records is a very big deal in the memory. So you cannot fit the whole graph into the memory, and hence it was really difficult to process a big graph using a single computer. And GraphX solves exactly that problem. Using GraphX, you will be able to load a graph which is not fitting into a single node's memory, you can load that graph over multiple machines. All right. So the basic idea behind all of this, whether you talk about graph, in case of graph, when we have to represent the graph as a graph, we have when you have to load the graph using memory, and the graph is divided again into a data structure called resilience distributed data set. Okay, whenever we talk about SQL also has something, a concept of a table where it has rows and all of this. A table is again represented as a RDD, resilience distributed data set. So resilience distributed data set is the part of the core of Spark. Now, in case of streaming, again, the data which is coming in is saved into RDD. In RDD is a in-memory data set which is divided onto multiple machines. So even if you do not understand it, as we go forward, you will understand what I'm talking about. Okay. So all of these library and framework, the most important part we need to understand is ability to represent data on multiple machines is one aspect. Second, ability to do the computation on the multiple machines is the second important aspect of Spark. Okay, so first is ability to load data parallelly on multiple machines, and this data is single data structure. Okay, single data structure you can load on multiple machines, part of it on one machine, part of it on second machine, part of it on third machine, and still the programmer can be heavily abstracted from the actual dynamics of distributing the data. That's where Spark comes in. So did I make any sense to you? So Ishwar is saying, so for streaming, we have to go for Storm. So mostly you won't have to. Okay. The if you require the so input ingestion can happen at a very fast rate. Okay. So there are two parts in stream consumption. We will discuss it in detail. So there are two parts in stream processing. One is consuming the data which is coming from stream. Okay, let's say you have a Kafka queue from which the data is coming at a very fast pace. Okay, now as part of any stream processing, we convert the input data which is coming at a very fast pace into bigger batches of data. Okay, and this bigger batch, if you are okay with the batch of 1 second, then Spark is good. But if you are not okay with 1 second batch, and you want something like a millisecond batch, then you would need to go for Storm. All right. Did I clear Ishwar? Yeah. All right. All right. So Ishwar is saying, so we can say streaming, we have to go to Storm. All right. So can we say the Spark is near real time versus Storm is real time? Okay. So yeah, sort of we can say that, but again, in case of even Storm, it's just I mean, kind of 100 millisecond kind of window is comfortable. Okay, or maybe 10 milliseconds is comfortable, but below that it becomes very difficult. Okay, so yeah, so nothing is real time, everything is actually near real time. All right, all right, good. So I hope I'm able to make it clear. We'll talk about these things again in detail, so no worries. We'll go into each and every aspect and we'll try to dig into it. Okay, all right, so let's get started. All right, to get started with Spark, first find out your Hadoop version. Okay, for us, the Hadoop version which we are using, let me log in into my Cloud Labs. Okay, so I can check Hadoop version. So it shows you clearly that it's Hadoop 2.4. Okay, it's Hadoop 2.4 here. And so accordingly, I'll go to Spark's download page. From here, you can basically select the latest version and then download the one which you are comfortable with. So because I'm using 2.4, so the one which is 2.4, I'll use it. Okay, and I can download this, or I can just copy the URL, and then after login to the server I can say wget and then this. Okay, I have already downloaded it, so I don't think it's required. Okay, so once you have downloaded it, and wget is a command which basically help you downloading Spark. All right, Mandy, do you want me to repeat? Which part do you want me to repeat? All right, and Jitender, are you able to see the current screen now? Right now we are on downloads page on Spark. All right. So Ishwar's question is, what is the best front-end architecture for Spark or Storm? So what I need to understand, what exactly you are looking for. Front-end architecture as in, because most of the stream processing or batch processing or whatever it is, these are background jobs. They generally do not have to present the data right away. But what we can do is you can push this data into some database or somewhere and then connect to this one using your front end and present the data as and when it's coming in. Okay, so for that you will basically have to keep on checking the background, I mean checking the database whether the batches have come in or not, and then represent the data to the end user accordingly. All right, all right. So right now, what I'm saying is that you can download it for your own sake. I have already installed it, and let me just make it available to all of you. All right. So in a classic case, keeping Cloud Lab aside, what you generally do it, find out, let's say you in your organization, you are trying to install Spark. You first find out the Hadoop version by using bin Hadoop or the whatever the wherever your Hadoop is installed, and then find out the version, and accordingly you download this Spark. And once you have downloaded, you can easily unzip this file using tar minus zxvf. Z is for unzipping and x is for extracting, and so on. So you can simply say this. Okay. And so using this command, you can quickly unzip this file. And once you do that, you will have this folder containing everything. All right. You'll have this folder which will have everything. Under this, the most important part for you is the bin folder. Okay. In bin folder, you will see the commands. There are two sets of commands. One is .cmd file and other is normal files. Okay. So .cmd is made for the Windows. So you can see inside this. All right. So what are we trying to do? We are trying to interact with Spark by using any of these tools. Okay. So I've just downloaded it here in my home folder, student folder. Okay. You don't need to download. I'll show you why. And you can basically start running this without Hadoop. Right now, when you say PySpark, it's not running on Hadoop. This is standalone version, but you can read the data from HDFS. All right. So this is the console of Spark in Python. All right. Now, if you want to run the Scala version, you can use Spark Shell. All right. This is Scala version of the command. So it's an interactive prompt. All right. So it needs to install. All right. All right. We'll have to look into that. Good. So you can run. So once you have downloaded and unzipped, so you don't have to download it right now on the cluster. You can download it in the local directory. Okay. And I can make it available to everyone by copying this to outside. I'm copying it to user/lib. Okay. And the way to copy it is, let me log into root. All right. So here I know that a student had downloaded it. Now I'm going to take Spark. So this is where we unzipped it. I'm saying copy this into user/lib and do it recursively. All right. Now if you see user/lib, here you'll see there are two versions of Spark. One is 1.1 and other is 1.5. Okay. And when we say ls-l, Spark folder is linking to that. I can delete Spark here. Okay, and I can say Spark 1.5 and Spark. Alright, so I'll create simple link. Alright, so all I did was very simple thing. I had downloaded Spark this folder, have put it in user lib folder, okay, and then make a symbolic link to Spark so that you can from your if you're logged in into Cloud Labs on Hadoop one, you can simply run you can simply run uh, something like lib user lib spark bin PySpark. Okay, so everybody can now run that. All right. So did I make sense, or it just went? What machine config is generally needed? So there are two questions from Ishwar Krishna. One is, all right. One question from Ishwar Krishna is Spark Storm don't have endpoints to consume. They do, yes, they do. So I mean that's what it happens. So all right, let me try to explain. So there is something called queues. Okay, we call them enterprise bus, enterprise bus, enterprise bus, or we call them data queues. There are many data queues. All right, anything that produces data continuously. Okay, such as Kafka and such as there are many one. Okay, there are many message queues. These are organizational these are organizational queue data structures from on which everybody keeps pushing data. Okay, Kafka is one example. All right, so let me finish this answer and then we'll carry on our installation. So from Kafka or any other queue, you can read data into Spark and then process it using Spark streaming libraries. Of course, here while consuming data from Kafka, you require Spark streaming libraries which provide facilitate pulling the data from Kafka. So as and when so Kafka, if you think about it, is a big queue. On on everybody keeps on putting data into Kafka and consuming the data from Kafka. All right, and so basically whenever there's a continuous programming, continuous as in the data is coming continuously and we are pushing the data, and we use things like this. Now your question, coming back to your question, so your question is probably in continuation with the UI. How do you display it in the UI? So there are many ways to displaying it to the UI. Okay, you can have you can have web application web application as a client. Okay, so your server is connecting to the web application as a web application connecting to Spark and Spark streaming, and displaying data to the user, right? Let's say you are running an analytics company and you have to display users who are there on your website on per second basis, not on microsecond basis, but per second basis. That in last 1 second, what who have been the user, and so on. Okay, for that your web application can connect directly to Spark, read the data, I mean via Spark streaming, and start showing it on your web application. Okay, does it make sense to you? Like the way Google Analytics displays to you? All right. Now next question is what kind of machine configuration we require for Spark? Okay, so since Spark is a little more involved process, so although it can run on any configuration, okay, but a machine with at least 512 MB is recommended. All right, good. Now next question is Kafka has its own storage. So in case of Kafka, if you think about it, Kafka behaves like a real-time storage. Lots of data is being pushed into the queue and lots of data is being consumed from the queue. So this data which is available in the queue is parsed into database. Okay, so Kafka has its own storage mechanism to keep a backup of the queue. In case queue fails at any point of time, it can recover its data from the disk. All right, it can recover its data from the disk. All right. So, Ishwar, are your questions answered, or is there anything else? So, I should do one thing. I should log in into. All right. So here again, we can download. All right, and then we can say tar minus zxvf. All right, that's not correct. So which is wrong? We'll have to go to this website and then copy this link instead. All right, we'll say wget. Now it's downloading. All right. So I'm unzipping it and then we'll see. I'm deleting all the things which I downloaded. And here we are. So in this folder, you can see bin/PySpark. So without anything, you can start Python, PySpark without having to connect to any Hadoop or any other resource manager. So it is running right now in the standalone mode. Okay, we did not configure it to run on HDFS so far. So it's running in the standalone mode. Okay, all right. So that was the basics of downloading installation. So again, if you want to make it to available to all the users, we'll move it to some public folder outside. But for that, I need to be root. I need to be administrator to do that. All right, here we have. So the architecture overview again is Spark is anything, any program you write, there are two parts to the Spark. One is called driver application, other is called Spark application. So driver application is something like the the prompt do you see here? Do you see prompt here? This is, you can say, driver application. Okay. So driver application doesn't do much. Okay. It sends the data it sends the data to the Spark application, and then it receives back here on the driver application, and then it launches another process. So driver application is something like a coordinator in the game. Okay, so this is the driver node or driver application, while Spark application is the one which does all of the job. Okay, so if you have four nodes, node 1, node 2, node 3, node 4, on each of these nodes, your Spark application will go and run. Okay, and then once your Spark application has finished processing, it can push the data. The driver application will receive and gather the data from all the nodes. Okay, and after that, it can launch the another pass or another work, another pass of computation, another computation round, and again send the code to Spark application. Okay, and Spark any application you talk about Spark, the application reads and writes data to the RDD. RDD is resilience distributed data set. Okay, all right, makes sense to you? Is this diagram clear to everyone? So if you have node 1, node 2, node 3, node 4, on each node, we will send our Spark application for running against a data. Okay, our application is never without data. We always say that this is our data, please run our code against each element of this data, or this is my data, please summarize it using our code. Okay, so which means our code will either do some sort of computation on the node itself and never return the results back to the driver application, or our application could be such that it brings data from all of the nodes and summarize it on the driver application. Does it make sense to you? All right. Ashish, Ishwar, Gaurav, Hiren, Jitendra, Mehdi. All right. Good. Good. So, Ishwar, you got your question answered? So in case one of the node goes down at any moment of time, the same Spark application will quickly start running against a node which is nearer to the same data. So if you have a huge data, you load it in RDD, that gets loaded across multiple nodes. You can see that this slab is a big data. You can think of it has got, say, thousands of data points. So some data points here, some data records here, some data records here, some data records here. And this RDD you can always imagine as a big array of uh, data. Okay, big array of objects. So each Spark application can create fresh RDD by churning an existing RDD. Alright, so when we run Spark, it runs in two modes. One is called standalone mode and other is called over the cluster. Okay, so running a standalone mode is like running the test cases on your desktop. If you have been from a background of Hadoop, then you must have used pig minus x local. In those cases, the pig does not connect to Hadoop, instead runs in the local node. Similarly here, it does not run on. So in standalone mode, it does not run on um, any cluster. It does not run on any resource manager. Instead, it runs on the same desktop, which means that on your machine, you can right away download Spark and start running in the standalone mode. Okay. All right. So you can start with, I think, the CMD file here. Let me just get out of it. So if you go into bin and VI, so I think it runs fine on Windows. All right. Let me just say Spark. Yeah. So it runs fine on Spark on Windows. Okay. Try it. I have not tried it on Windows yet. If you want, you can try. So you can simply run. Okay. So standalone mode you can run on Windows as well on a single machine, while on cluster there are two modes. So there is another use case of standalone mode. The standalone mode is used when you want to do you have multi-cores. Okay, multiple cores. If you have a processor or a supercomputer having multiple cores, you can utilize all multi-cores using our using Spark. Okay, so for parallel computing, you can use Spark to do the work on the local machine itself. All right. But running in standalone mode does not make sense much unless you are having multiple cores. Okay, so for most of the time you will be running Spark on the cluster. Okay, so for production environment, you use generally the cluster. You run Spark on top of cluster rather than running only on one machine. Okay, so you can run you can run Spark on top of the existing resource manager such as Yarn or Mesos. The beautiful part is that for running Spark on Yarn or Hadoop cluster, you do not have to install Spark on all the nodes. Okay, only the node from where you are scheduling the work, you are launching the work, you are handing to over your work to the Hadoop cluster, you only have to install or download Spark only on that node. Okay, so you don't have to install on the whole cluster. All right, all right. So basically, when we are running in the standalone mode, and say when we just launched just now, we launched this. We said PySpark. Okay, we said PySpark, or we said, okay, we have to say dot slash. Dot slash means in the current folder. Dot means current folder, slash means inside. All right, so from here we can start working on Spark, but this is just running in a standalone mode. All right, so the standalone, in the case of standalone mode, where if you try to correlate with driver application, Spark application, it's the same node having both the things. The RDD, the whole RDD on the one node. There is a Spark application, there is a driver application. Driver application keeps on launching a Spark application on the node and gets a work done. Right? Make sense to you? Either either you can simply say things like, while running, you have to specify which one is the resource manager by saying dash dash master. Okay, so if you say dash dash master local, you are going to run it on the local cluster, local nodes. I mean, in the local mode. So, or standalone mode. At the same time, when you start a Spark, this is the UI which it provides to interact with the Spark on the 4040. It shows you what are the jobs scheduled right now. There are nothing scheduled. Then what are the stages? Okay, so this service has been launched because we have started Spark Cell. If we exit, then that service will shut down. Okay, now it's shut down. Make sense? All right. So standalone again is a Spark without any resource manager on a machine. It is used only for testing and or to utilize multi-core abilities of a machine, meaning for parallel processing. Okay, if you have a single machine and having 10 nodes on the same machine, 10 cores, 10 processors on the same machine, then you can utilize uh, Spark standalone to run. Okay, now let's take another case. So far we have only run this particular the command line. Okay, so this is a standalone mode. Again, we are only talking about standalone mode right now. Okay, and here we can start interacting with Spark. So let's say we have a big array. So right now we are saying my array equals some list of numbers. Okay, this is our list of numbers. All right, now let's say this list of numbers is really big. It's a, say, a billion records in this list, and you want to do some computation on it. So you can say something like my RDD1 equals to, these are your variable names, all right? These are your variable names. And you can tell Spark to parallelize it, okay? So what we are saying, take this data set, distribute it over the cluster, and whatever is the result, give me the handle to it, okay? So we got the handle to it. Now on top of this handle, we will do all sorts of magic. Right now we are just saying whether it has been loaded or not. So it's saying yeah. So take one means give me the first element. Now if you have to do some operation like find to the power n, okay, let's say we want to say p uh, my power function or my cube, okay, and we are writing a function called myCube, which basically returns x into x into x. So this is our function which we are creating. So right now I'm just trying to demo you how to use the interactive shell. So for that I wrote a function in Python called myCube, and all it does is on anything it is applied, it gives you the power of that, okay. Now you can do RDD2 equals to RDD1 and then say map, okay, my cube. So even if you did not get any of this, don't worry, things will be very clear as we go forward, okay. And now which means RDD2 will have all the elements of RDD1, just that all the elements will be cubed. So we can say RDD2 get me all the data, and it will, you can see that all the numbers have been cubed. Okay, so we were able to do a fair amount of computing on each element. All right, so Mehdi's question is, what is lazy evaluation? Good point. So did you just notice something when the processing, where when I said something like this, nothing happened. It just took an instruction from me that it is supposed to execute my queue function on every element. That's the meaning of this particular thing. It means please execute my cube against every element of this RDD, meaning cube each of the numbers. All right, but when I said this, it just finished. It did not do anything. But when I say, show me the data inside RDD2, then it starts working. Do you see? It now started working. This is lazy evaluation. It did the work only only when needed. It did not do the actual cubing earlier. It The cube is happened when we said collect. Give me the data. Collect means bring the data from RDD to local. So the moment I said give me the data, let me have a look, only then it started processing it. That's why we call it a lazy evaluation. All right, make sense to you? So Jitan's question is, will you provide function and their description? Of course we will. Okay, this is just a demo, and the problem with any tool is, if I do not give you a demo, then you will not feel comfortable. If I do not, if I'm giving the demo, then there are few things you may not know right now. All right, so you'll have to little bit take care of that part. All right, good. Now there's another example I want to run. So far we were just running the our example of hello world. Now let's try to solve a real problem. Let's try to compute the area of a circle. All right. So anybody remember area of circle? What is area of circle equals to? Anybody? Quickly, please. How do you compute the area of circle? Yes. So it's pi into r into r. Okay. So the purpose of this computation is to find the value of pi. One of the technique in finding the value of pi is to basically find the area, and then find the pi. Okay, if you know the area of a circle, then you will be able to find the values of pi, right? Let's say you have r equals to 1. Okay, so area of circle will be equal to pi, right? So if you know the area of circle, you can say that's the value of pi, right? And how do you find the area of something? You go from left to right, for all the points, find out which are the points lying in the circle by using the Pythagoras theorem. If the point is lying in the circle, you just count it and sum up all such points. Okay, that becomes the area of circle. That's what this piece of code does. You can take a look at the, okay, so basically from left to right for all the points in the square of 1 by 1, you keep on noting down all the values. Okay, all right, that's what this program does. All right, you can take a look at this code, which is basically computing the area of circle. All right, it's basically going from left to right, from where is that? Yeah. All right, now this computation can be divided very well by dedicating by splitting this circle into a grid of squares, and let individual nodes compute the number of values inside the circle, right? That can be divided amongst many people. That's what this particular code does. All right, but right now going into more details will be a little difficult. All right, so let's try to run the example. It's an example code provided by Spark guys. Okay, it's example code provided by Spark people. Let's try to do that. Okay, not here, but from the command line. Okay, so I'm saying here, is Spark submit. I'm submitting a job. Okay, and the job is this particular class. All right, and this class is available in the jars. So this is an example provided by Spark itself. If you see in the folder called lib, you will see Spark dash examples. Okay, and all it's trying to do is, using multi-threads or multiple machines, it is trying to execute it, trying to find out the area of the circle by counting total number of points that are lying inside the circle, and the total number of points which are outside the circle too. If you segregate them, then you can easily compute the area of the circle. Okay, this is probably the most brute force method you will ever notice. Now you can see that it has computed the pi roughly to this level. Okay, and what is 10 here? You see the last value as 10. It means break our grid, our circle into 10 by 10 parts, which mean 100 parts, and then do the computation. All right. Is everybody comfortable with what I just did? Here we computed the value of pi. If you break, instead of breaking it into 10 by 10 grid, if you break it into 2 by 2 grid, the value of pi will be very rough. Okay, you can see that is 3.1, 3.1216. What was earlier? 3.14136. Yeah. So now it's coming, not coming very close. All right. So that way we were able to do the computation of pi by computing the area and then finding out the value of pi. Good. So Gaurav's question is, since we are mentioning, does it also launches 10 Spark job as we specified 10? Okay, let's have a look at what this code is doing. We will know what this code is doing. So I mean, here you can see that it's a Spark, I mean, written in Scala, and here you can see that the arc's length is this, okay, and number of slices. So it's basically number of slices which it does, and right now it does not use the many executors. Okay, the executors you can specify from outside. You can specify executors from here. I'll show you that piece of code, that while submitting a job, you can you can decide upon number of executors, number of processes on each node. All right, that is something you can do it from outside. All right. Okay, so Gaurav's question is, how can we check number of Spark job? You can go to this UI and have a look at it. Right, while you are running this diagram here, so it's if you run it, then you'll be able to see. All right, here it's temporarily starting the service and then setting it down because it's a sort of a batch process. All right. In the case of cluster, the jobs will reflect in your Hadoop cluster as well. If you are running Spark on Hadoop, it will show you clearly that your job is being run on the Yarn cluster. I'll show you that. All right. Good. Good. All right. Now there are two differences here. There are two ways you can either, while running in the standalone, you can either say master local, or you can just completely skip this part. Still it will run in the local mode. All right, there are various commands which are part of Yarn. The first one is PySpark. PySpark basically gives you the Python interactive shell to talk to Spark. There is an extra object called SC that is your gateway to Spark. Okay, Those who are not comfortable with this idea of, let me show you them. So if you run Python, you see there is a command here. It's an interactive cell. Interactive cells are very good. They started with a couple of languages, and they are really good for doing the computation in, okay, the ad hoc computation. So looks like my net connection is flaky. All right. Are you able to hear me now? There was a connectivity issue at my end, so I've shifted the network here. All right, all right. So we were talking about PySpark. So before that, I would like to introduce you quickly to the Python console. Okay. Let me try to do that. So let's go to Hadoop 3 and log into Spark 1. All right. Okay. So if you have a look at how does Python command prompt looks like. So this is a command prompt. This is not unlike your usual programming where you write a program then execute it. Here Python provides one extra feature. Extra feature is that even though you can run your script like usual, but you can evaluate each statement quickly. If you have something like a simple program, you can write here. You can say things like my cube x and say print, say hi. All right, and let me just write it properly. Def, let's say my cube, the function which we were trying to run earlier, we can say return x into x into x. Okay, now you see, if I say 10, it'll quickly give me 1000. So we were able to quickly program. That's the strength of any of these interactive shells. So the way people work in with these newer programming languages, specifically those who are learning, they keep their editor open, as well as they keep the interactive shell open and keep on typing the statements here on this interactive shell to check whether a statement is valid or not, and accordingly they keep on building the program in the text editor. Okay, so yeah, so this is the way it works. In the similar spread, Spark has come up with the interactive shell. Okay, so this is Python's interactive shell, right? It's basically the Python's interactive shell with one extra variable called SC. So SC and Hive context. I mean SC and SQL context. These are the two extra variable available over what is provided by Python in this interactive shell. All right. So if you want to interact with Spark directly, you can use Spark context. If you want to interact with the Hive context provided by Spark, then you can use SQL context. Okay, so this is basically a command line way of doing things, while there is another way of doing the things as well, which is Spark shell. Okay, so so Spark shell is equivalent of PySpark, but for Scala. Those who are comfortable and those who want command line way of doing things, they can simply run bin Scala Spark shell, and this is basically the Scala command prompt. Scala is similar to Python, a little bit more for the parallel computing. So Scala is a programming language, and Scala also provides you the command line similar to Spark. All right, you can see that. So yeah, now Spark class is something which is, to submit a full program. You wrote an application and you want to submit. You want to submit, then you use Spark Submit. Okay, but if you want to run a program, a Java class locally, just to test whether it works or not, you can use Spark class. If you want to execute interactive shell in which you can type the okay, in case you want to interactively work with SQL step by step, as in you run the query, it gives the results, you can use Spark SQL. All right. So, okay. So Mehdi's question is that I could not find any good documentation to learn Kafka and Scala programming. Do you have any recommendation? I'll send it to you. Okay. Okay. Also, if our time permits, then we will also go into the basics of both. Okay. All right. So Spark Submit is for submitting a job for in Python or Java to the Spark. And Spark class is just to run a Java class standalone with with Spark libraries. And to interact with the Spark in SQL, you can use Spark SQL here. You can use Spark SQL bin/Spark. All right, you can see that. So this is where you can write your queries. All right, there is no such table as dual. All right, we will have to first create table and then start working on that. Right? The idea was to just show you that there is something. Now this is something new, which is Spark R. Okay, so it basically gives you an interactive shell, just like R also give. If you are from R background, you will notice that you can run R. You can run R exactly in the same manner as you do Python. Okay, there is an interactive shell available in R. Okay, like I think I have on my time machine here. So yeah, you can see that this is my R terminal. Okay, this is my R terminal. So here I can code in R in the same way I was working with Python. All right. So Spark R provides you an interface to code or to write your programming R and get it done on Spark. All right. Jitin's question is that can I use UI like Hue like UI? Right now there is not a UI. There is no UI available for that, but people are working on that. All right. All right. Let me just make a note of it. 5th September. Sorry, 5th September, and what is the date today? 12th. Session 2. All right. So that was about the overview of the binaries. Yes, Gaurav. All right. So Gaurav's question is, can I write R program and run it on the Spark for some analytics? Yes. So let's say, I'll explain to you the workflow. And this is something amazing which has happened in recent past. And that's why Spark is becoming the first choice of any data scientist. Okay. So anybody who is learning in cleaning data, forming it into some, I mean, running machine learning on it or running statistics on it, they basically take the data, start working in R. Okay, visualize it using R and all of that. Now, problem with R is that if your data goes beyond your RAM, if the data goes beyond the RAM, then R is not able to handle that. That's where the trouble starts with R. Okay? So in case you started working in R and you realize that you are facing challenges, you can port your code to Spark and start using Spark. Okay, and you also, in case you are handling some 100 gigabytes of data in R format, then it would be only possible to do that using Spark, not with R. Okay, and you will also set up your cluster and then you will run your. The other point which you should remember is that in case you are having your R code that is using some existing library, let's say you're working on some DNA research, genome research, and there are many libraries of genome in R, but there is no library in Spark, correct? But you can import that library into Spark and it will behave normally. All right, you can import most of the libraries into Spark and get them running. All right, so that's another very important thing to remember. Make sense to you? So you can basically run your program written in R in Spark, as well as you can load the libraries of R inside Spark. Alright, we will see that later. Alright, let's have a break. Thank you, Ishwar. Break for 10 minutes. 10 minutes, okay, right? And back by 8:45 a.m. IST. Right? 8:46 a.m. IST.